Hi, we're on 9.3, the geometric sequences series part 4. And on these, we're finding the partial sums, the S of n's. And the formula that we'll be using for this section is S of n equals a sub 1 times 1 minus r to the n over 1 minus r. I wish we had a lot more time to play around with this stuff so I can show you where the formulas actually come from for all these problems, even in 9.2. I did a little bit in the 9.2, but it takes a long time actually to come up with these formulas. And I wish I had a little bit more time to do that. But anyway, so what we're doing here is we're going to find the sums of these four things. Now, I want you to understand the first one and the second one will not have numerical answers. And it's because they're not all numbers in the problem. If you look at this one, it's 1 over 2 to the n. So like we did back in the arithmetic sequences when we were doing sums on this one's not a specific term. So we don't know how many terms there are. There's just n terms there. Now this one, same thing here. Just this one and this one's pretty much the same thing, just written out different ways. Now these two actually will have a numerical, tangible answer because you can plug 1 in, get a number, plug 2 in, get a number, but the top number is 6, not in. So you actually will put that last number in there. So you will get a tangible number on this one. And obviously, example 4 will get a tangible number. As a matter of fact, you're sitting there thinking, well, I'll just pull out my calculator and add those numbers up. I don't want you to do it that way. Okay, that's not the way we're going to do it. Now, so let's go back to example 1. So it's 1/2 plus 1/4 plus 1/8 plus dot, dot, dot. So let me write the formula down. So S of n equals a sub 1. I know that number is 1/2. 1 minus r to the n over 1 minus r. So the question is, what's the first term, which obviously is 1/2. So the first term is 1/2. The problem is, what is r? Well, the second term is 1/4, and the first term is 1/2. So to get from the first term to the second term, you have to multiply 1/2 by 1/2 to get 1/4. So it appears to be 1/2. 1/2 times 1/2 is 1/4. 1/4 times 1/2 is 1/8. So it seems to be the ratio. So r is 1/2. So you're like, what do you do now? You don't know what n is. I know. That's your point. You don't know what the n is. So what you're going to do is just put everything into the formula except for the n. So in essence, what you're getting is a formula itself. So the first term is 1/2. 1 minus r is also 1/2 to the nth power. And then 1 minus r, which is 1 minus 1/2. This kind of comes out fairly nice, actually, because 1 minus 1/2 is 1/2, and these cancel. So I know I'm canceling out 1/2, and technically you probably should invert and multiply it, but they're the same number, so I can cancel them out anyway. So I'm left with 1 minus 1/2 to the n. So yeah, what's good is this formula if you don't get a tangible number? Well, if I'll tell you this. If I had 3 terms, 1, 2, 3, and I knew I had 3 terms, 1/2 plus 1/4 plus 1/8, and I wanted to add these numbers up, 1/2 plus 1/4 plus 1/8, an 8th grader, what they would have to do is they would have to take these 3 numbers, get a common denominator, which is 8, put them all together, and add them up with the common denominators. So you can imagine if you had the next number, which is 1/16 in that, and then you had to add those 4 numbers, which you had to get a common denominator with all those numbers, which would be more painful. So, but if you only have 3 terms, to get the answer, you can do it what an 8th grader would do, but you could also do this. Plug 3 in there, because that's how many terms you would have. 1/2 to the third is 1/8, and then 1/8, 1 take away 1/8 is 7/8. So 7/8 is what these 3 would add up to. And so if you add 1/16 in the mix, then you have 4 terms, 1/2 plus 1/4 plus 1/8 plus 1/16. And what an 8th grader is going to do is they're going to take those 4 numbers, is going to get a common denominator of 16, and then start adding them up. But what we would do is, since we have 4 terms, 1/2 to the 4th is 1/16, and take 1, take away 1/16. It's very easy to do. It's going to be 15/16. So as you can see, it's getting pretty easy to add them up. So if you put another number, it'd be 1/32, and what an 8th grader would have to do is get a 1/32 and all those other 4 numbers before it, get a common denominator of 32 and add them up with common denominators? Not us. We would just put 5 in there because there'd be 5 terms now. 1/2 to the 5th is 1 over 32. And then 1 take away 1 over 32 is 31 over 32. So we get the answer a lot faster than they would do. So what this creates for us is a formula to find sum of any terms you want. So although you don't get the tangible answer that you can actually touch and feel and not feel good about it because you don't get an answer that you can see, you do get a formula that if you do know how many terms you have, it's easy to find that actual sum. So that's the point. That's why they do these types of problems. Now, example 2 is the same thing, okay? But it's just written a different way. You plug in 1, you plug in 2, you plug in 3. So what you would end up doing if you do it the way they had it initially, you plug in 1, you'll get 3 times 2 to the first, which is 6. And then 3 times 2 to the second, which is 12. And then plus 18, plus dot, dot, dot. And you keep going. No, it's not 18, it's actually 24. Because 3 out of 2 to the third is 8. 8 times 3 is 24. Yeah. And then you go all the way out to n to be 3 times 2 to the n. So now it looks exactly like example 1. So now you can do it directly the way they have it here. So you just say, well, S of n equals a sub 1 times 1 minus r to the n over 1 minus r. You still need to find the first term, which is 6. And 1 minus r. Remember, r, you can do it by 12 divided by 6, which is 2, or you can just look at the base. So the base is 2. So it's 1 minus 2 to the n over 1 minus r, and r is 2. So 1 minus 2 is negative 1. That's negative 1. And so it turns out to be negative 6 times 1 minus 2 to the n. Yeah, you can multiply by negative 6, but I would strongly suggest not to go there. The reason is because people will make a mistake the second multiplier. Negative 6 times 1, everybody gets negative 6 and everybody's happy, and that's right. But the problem is on this one. Negative 6 times 2 to the n is not a positive 12 to the n. And that's where the people mess it up at. So I would just leave it like that. So if you're really wanting to multiply it out, it looks like this. Negative 6 plus 6 times 2 to the n. You cannot combine 6 and 2 with a product. You cannot make it 12 to the n. Again, it's the order of operations. So, but like I said, I would just leave it like this one. But there's really not much difference between example 1 and example 2. But when people see these two problems, they think they're talking about two totally different problems. It's just this one's getting presented in an expanded form, and this one's presented in sigma notation. So it's presented a little different way, but you're doing the same thing. Now, examples 3 and 4 are given to you, and your answer will be a tangible number. So the good news is we don't have to worry about formulas involved as a result. We just get an answer. So it's going to be S of n equals a sub 1 over 1 minus r to the n. That's not right. A sub 1 times 1 minus r to the n over 1 minus r. This is a partial sum. So now what we do is, how many terms do we have? We're going to start at k equals 1 to 6. So it's going to be s sub 6. Now we'll need a sub 1, so we'll need to know the first term. So we'll need to plug in 1. So be 5 times 1/2 to the first, which is 5/2. So that's 5/2. 1 minus r, and r, remember, is the base, which is 1/2. And then that's to the 6th power. Over 1 minus r, 1 minus 1/2. So the good news is you get a tangible number. The bad news is now you got to do more math, because there's a lot more math involved when there's just numbers. A lot more calculations you got to do. So this is going to be 5/2. 1 minus, now 1/2 to the 6 is actually 1 over 64. So it might take you a little time to do that. And then 1 minus 1/2 is 1/2. If you invert multiply, you get 5/2 times 1 minus 1 over 64. I'll deal with that in a minute. And then times 2 over 1. And the 2's cancel. So you get 5 times. And then 1 minus 1 over 64 is actually 63 over 64. And nothing reduces, nothing cancels. So all you can do is multiply it out. So 5 times 63 is 303 divided by 64. And I suppose that's just under 5. Just below 5. So if you added 5 halves plus the next number that becomes behind it, which actually would be 5, let's see, 5 over 4, and then 5 over 8, and you add them all up, you're all done, said and done, it's 303 over 64. So, which like I said, is like 4 point something. So, but anyway, so that's how you do those. Now, example 3 is more of a sigma notation. So this is more in the line of example 2, because they're both in sigma notations, or both compact form. This one right here is more an example 1 point of view, except you actually do know the last number, 486. But you still use the same formula. S of n equals a sub 1 times 1 minus r to the n over 1 minus r. So you get S sub, you can actually count the terms here, 3, 4, 5, 6. It's not too bad on that one. It's 6 terms. And then a sub 1 is 2. So it's, everything's basically staring you in the face except for the r. So you got to take 6 divided by 2, and that's 3. So the ratio is 3. So it's 1 minus 3 to the 6th over 1 minus 3. So 2, 3 to the 6th. See, that's going to be 729. And then, I think, yeah, I think so. And then 1 minus 3 is negative 2. So you get the 2's cancel. So it's going to be negative 1 times 1 minus 729. And I think it's all, after all the smoke is clear, it's going to be 728. And that means if you add up 2 plus 6 plus 18 plus 54 plus 162, 486, what an 8th grader would do, they get 728 as well. But you can't do it that way, remember. You have to actually use the formula. Because what could happen is I could give you a problem and that has a lot more than just 6 terms. I might give you one that has 60 terms. The number would be huge. Because by the time you get out that far, the numbers are going to be in the 5 or 6 or 7 or 8 digit numbers. So those are going to be some huge numbers. So I keep the number small so the numbers don't get too big. But as a trade-off with you, you have to show me the formula. So, but anyway, so example 1, example 2, example 3, example 4 finds the sum of partial sums. What that means by partial sums is you have a stopping place. You may go from you may have 6 terms, you may have 6 terms there, you may have 10 terms, but you do have a stopping point. So anyway, this is part 4. We got one more part, and that's part 5, and that's going to be the infinite geometric series, and that will take us a little while as well. So stay tuned.